Sequence A1, A2, A3 is defined recursively by A1 equal to 0, A2 equal to 100, and AN is equal to 2A n minus 1 minus n minus 2 minus 3. Find the greatest term in this sequence. Now, first of all, this isn't an arithmetic or geometric sequence, so let's first rearrange this equation over here. We can make it so that it reads an minus 1 minus an minus 1 minus an minus 2 is equal to minus 3. Now, this makes it so that an itself has to be a second degree quadratic function. Now we know the value of a1, which is 0, a2 is 100. So we can just put n is equal to 1 and n is equal to 2 into this over here. Then we'll get two equations for three variables. But we need three equations to solve for three variables. So now we can just find the value of a3 just by plugging into this over here. Since a3 is equal to 197, we can put that in. And we'll end up with these three equations. So we can solve this to make it so that a is equal to minus 3 divided by 2, b is equal to 209 divided by 2, and c is equal to minus 103. Let's put that into our function over here. We end up with an is equal to minus 3 divided by 2n squared plus 209 divided by 2n minus 103. Now what do we do to find the greatest term in this sequence? Well, we're going to do something called perfect square, where we take out the number to make it so that it's a perfect square times plus something a little bit extra. So first of all, what we need to do is take out minus 3 divided by 2, because that's the constant that's multiplied by n squared, which has the highest degree. So we're left with minus 3 divided by 2 times n squared minus 209 divided by 3 n plus 203 divided by 3. Now to make this a perfect square, we need to get rid of n squared and minus 209 divided by 3n. So we're going to be left with minus 3 divided by 2 times n minus 209 divided by 6. This is because this is 209 divided by 3 divided by 2, making it so that both of these are both n squared and this are canceled. Now we're also left with something a little bit more than that left over, but we don't really need to know the value of it, so we're just not going to find out. We don't need to find it out, so we're just not going to. So now we had to figure out the smallest value for this over here. Well, oh wait, sorry, I didn't write squared. Sorry. So we just had to find the smallest value for this over here. Now, since 210 divided by 6 is equal to 35, that means 35 must be the value for that. So we put 35 into this over here. We're going to get minus 3 divided by 2 times 35 squared plus 209 divided by 2 times 35 minus 103, which is also equal to 11717. There we go. That's our answer. We want to find k given that f0 is equal to k and fn is equal to fn plus 1 minus 3n minus 2. Also, f minus minus 50 is equal to 4,000. Now, what we need to do is the same what we just did right before. Rearrange this equation over here. We get that this is also fn plus 1 minus fn, which is equal to 3n minus 2. Again, we only get this by rearranging this over here. So that means that fn is also a second degree polynomial. So we have this over here. Now, since f0 is k, that means if we put 0 in, we're also going to get k. That means we're going to end up with c, meaning that k is equal to c. If we can find out f1 just by plugging n is equal to 0 into this over here to get that f1 is equal to k plus 2. Similarly, we also find out that f2 is equal to k plus 7 by plugging 1 into this over here. Now, so we're going to be left with these three equations. Using these, we can substitute every value of c with k because they're the same thing. So if we're left with that, we can, well, let's just write this as k and this is k. Now you'll realize that both sides have k, so we can just get rid of it. So now we're just left with these two equations over here. So obviously a is equal to 3 divided by 2 and b is equal to 1/2. So by putting that into our equation over here, we're left with fn is equal to 3 divided by 2n squared plus 1/2 n plus k, because we replaced it with c. Now, there's one thing left in this problem that we haven't used yet. This. So let's just put the value of f minus 50 into this over here. Well, so f minus 50 is equal to 3 divided by 2 times minus 50 squared plus 1/2 times minus 50 plus k is equal to 4,000 because f minus 50 is equal to 4,000. So now we're left with k is equal to 200, k is equal to 275. And there you go. That's our answer.